All right, also today I'm going to be talking about solving logarithmic equations. If you haven't done 5.5, our simplifying log notes yet, you need to make sure you do those first before you start this, or else you're going to be a little confused. But we're going to kind of be building and expanding on a lot of those skills we built up. So we discovered what a logarithm is, we simplified some logarithmic expressions, and now we're really building up to solving logarithmic equations. Okay. So we already had some equal signs, but now we're going to have some x's in different spots. So we're going to look at numbers 1 through 4. So number 1, we have log base 2 of x is equal to 3. So this one I want to solve for x. And right now, you have the exponent and you have 2. So you might be like, Mr. Arbonner, you know this. But let's use all of our skills to actually solve this one like we normally would. So moving our base of 2 over, I'll use my hook method to change this into an exponent. So this would become x is equal to 2 to the third. 2 to the third would be 8. So x is equal to 8. So relatively straightforward on number 1. If we convert from logarithmic form to exponential form, we can go ahead and solve it for x. Let's look at 2. So we have 3 to the x is equal to 3 to the 1. So we have a couple different ways we can do this one. So we can do our same basis. So 3 and 3 are the exact same. I add a power of 1 just so we can see. So this would mean that x is equal to 1. That one's pretty straightforward. But let's say we wanted to do our hook method instead. Because remember, we got lots of tools in our tool belt at this point. So if I did my hook method instead, I have 3 to the x is equal to 3. I can take my base of 3. I can move it over to the other side. My x would come down. So this would become x is equal to log base 3. From here, still have my power of 1. Log base 3 and 3 would cancel out. So we would get x is equal to 1. So we got some different things we can do now to start solving these logs. You got options. You got different ways you can work them out. So let's look at 3. We have log base x of 16 is equal to 2. So let's use our hook method. I'm going to move x over and 2 up. And the reason why I really need to do this one is because I don't know the base. So it's something squared is going to be equal to 16. You might be able to guess that, but they're not always going to be so easy in terms of the numbers. So this would be 16 is equal to x squared. And from here, I want to solve for x. So I can take a square root, and the square root of 16 would, of course, be 4. Now, in Algebra 2, you talked about when you take a square root in a problem, you always get a positive and a negative. The reason why I'm not going to include the positive and negative here is because x is a base, and we can actually never have a negative base for a logarithm. That's no good. So we're only going to worry about the positive solution for here. Last but not least, number 4, we have 4 raised to the power of x plus 2 is equal to 64. I'm going to show you 2 different methods in this one. So the one that makes the most sense to me is to change both to be a base of 4. So 4 to the x plus 2 is equal to 4 to the third. So 4 and 4, same base, x plus 2. And 3, I can set those equal to each other. So x plus 2 is equal to 3, canceling out those bases. And then from here, of course, I can just solve for x. So minus 2, and we get x is equal to 1 as our final answer on this one. So another way we could do this, we could do our hook method instead if we wanted to get everything on one side. So if I did my hook method instead, I can take my base of 4 and I can move it over to the other side. 64 would go up. Or actually, that doesn't make much sense on this one. So we're not going to do that instead. Sometimes I decide that I don't want to do things. So we're just going to leave it like that. So you got a couple of different ways, y'all. I want you to go ahead and try some of these skills now on 5 through 10. And I think I just noticed that I was unpaused that whole time, but that's all right. So you stayed along with me and watched me work all these out. Then you already know some of this. But let's talk about some of these. So we got 5, n is equal to log base 10 of 100. Log base 10, I can change that 110 squared, cancel out the 10. So we get n is equal to 2. On number 6, log base 10 of 125 is equal to 3. I can shift that over into an exponent. So 125 is equal to n to the third. Then I can cube root both sides, and that means 5 is equal to n. On number 7, log base 3 of 3 to the fourth is equal to n. So 81 can be changed to 3 to the fourth. Log base 3 and 3 to the fourth, those bases of 3 cancel out, so we get 4 to the n. 8's probably one of the weirder ones, but I like to change it over to exponential form. 1/16 is equal to n to the negative fourth, which means 1 over 2 to the fourth is equal to n to the negative fourth, which means 2 to the negative fourth is equal to n to the negative fourth. So exponents are the same, which means bases need to be the same. So that would mean n is equal to 2. Then on number 9, it is a common log because that 10 isn't written. So we add in the 10, shift it over. N is equal to 10 squared, which means n is equal to 100. And then last but not least, log base 4 of n is equal to 1. Shift that over to exponential form. We get n is equal to 4 to the first, which means n is equal to 4. So slightly different ways. I tried to use the best method I thought for each of them, but you can really, there's a lot of different things you can do to solve each of these. And a lot of them, you can kind of think through them. You don't need to necessarily show as much work. So let's look at 11 and 12 real quick. So we're going to use a couple more skills to try and do these a little bit more complicated ones. So we have log base 3 of 4x plus 7 is equal to 2. So we want to get rid of the logarithm so I can get to that 4x plus 7 that's trapped on the inside. So I'm going to take my base of 3. I'm going to move it over to the other side. 2 is going to come up. And this should be familiar. We've been doing this. So that's going to mean 4x plus 7 is equal to 3 squared, which of course means that 4x plus 7 is equal to 9. So from here, that's just a linear function. Once I moved it over, I got that exponent. Now I can just treat it like anything else. So minus 7 to both sides. We get 4x is equal to 2. Divide by 2 on both sides. And we get x is equal to 1. So all we're doing is we're adding in kind of our logarithm skills, our property of logarithms, to try and make our solving a little bit simpler. So nothing too crazy. We're just kind of, this is the natural evolution of what we've been working on over the last couple of days of notes. So number 12, something a little bit different. We got 2 logs in the problem. So I can't just do my switch. I need to get it to a single log to be able to do my hook method. But we talked about our property of logarithms last time and how if we have multiple logs, we can combine or condense the logarithms into a single one. And in this case, we have this plus sign right here, which means I can combine this into a single logarithm base 5 of 2. I'll write it the other way so it makes a little more sense. Of x plus 6. And then times 2. And that's still equal to 3. So when I have those 2 logarithms like such, I can combine them into one single logarithm. And because it's addition on the outside, it becomes multiplication on the inside. And I'm going to simplify this inside just a little bit because I can before I do my hook method. So this would be equal to log base 5 of 2x plus 12. And that's, of course, equal to 3. And now I can do my hook method to get rid of my logarithm. So this would be 2x 2x plus 12 is equal to 5 to the third, which 5 to the third, we've already done this one a bunch. That's equal to 125. So 2x plus 12 is equal to 125 minus 12 and minus 12 to both sides. So 2x is equal to 120, not 120, 113 divided by 2 on both sides, and we get that x is equal to 113 divided by 2. So 12 is really a culmination of a lot of the different skills we've practiced over the last couple of days. So I want you to go ahead and try 13 and 14 using all these different tools. All right, y'all, let's talk about 13 and 14 real quick. So on 13, I have two logs that are being divided, so I can combine them into a single logarithm. That becomes natural log of x minus 6. Or sorry, I have two logarithms that are being subtracted, so I can combine them into a single logarithm with the insides divided. So it becomes natural log of x minus 6 divided by x plus 2, and that, of course, is equal to 0. Then I can take my base of e, I can shift it over to the other side, so that will become x minus 6 over x plus 2 is equal to e to the power of 0, which is equal to 1. So x minus 6 over x plus 2 is equal to 1. The only way I can get rid of that fraction is by multiplying by the factor that's on the bottom. So multiply both sides by x plus 2. We get x minus 6 is equal to x plus 2. And then when I'm simplifying this one out, trying to get x's on one side and my numbers on the other side, I get that 0 is equal to 8, which is no good, okay? So this one, it actually doesn't have a solution, which could happen sometimes. We could have that with the equations. Sometimes equations are written that don't have a solution. That's happened before, so we're just going to leave it like that. We've done all the work to prove that this doesn't have a solution. 14, a little bit more straightforward. We have 2 log of x plus 2 is equal to 4. So I can actually divide that 2 first. The big thing to keep in mind, though, is that I don't divide the inside of the log. The inside of the log is like any square root or parentheses. We don't mess with it. It's kind of protected. So dividing both sides by 2, we get log base 10 of x plus 2 is equal to 2. Using my hook method, the log goes away. It becomes 10 squared over on the right. So x plus 2 is equal to 10 squared, which means x plus 2 is equal to 100. Minusing 2 and minusing 2, we get x is equal to 98 on both sides. So let's keep on going. Let's keep adding skills as we keep trying to solve our logarithms. We're just about done with all of our different skills. So I want you to go ahead and try 15 and 16 for me this time and see if you can do those as well. All right, y'all, let's talk about 15 and 16 real quick. So 15, you can do your hook method and move the 4 over if you prefer. I like same bases. So changing 64 to be 4 cubed, I have 4 to the x plus 7 and 4 to the third. Bases are the same, so both 4's cancel out. So we get x plus 7 is equal to 3. We can subtract 7 and subtract 7, which gives us x is equal to 4. Pretty straightforward on that one. 16, we have log base 2 of 1 over x plus log base 2 of 3 is equal to 3. I have that addition sign on the outside, so I can combine it into a single logarithm with the insides multiplied. So log base 2 of 1 over x times 3, which 1 over x times 3, that's the same as 3 over x. So now I have log base 2 of 3 over x is equal to 3. I can hook my base over, so it becomes 3 over x is equal to 2 to the third power. So 3 over x is equal to 2 to the third. I can simplify that 2 to the third to make it 8. So I have 3 over x is equal to 8. Multiply both sides by x to get it out of the bottom of that fraction. We get 3 is equal to 8x, and then divide both sides by 8, so we get x is equal to 3/8. Okay, our last one that we're going to talk about, y'all, we've kind of already done it, but I wanted to see it with logs. I wanted to see it with exponents, both of them. So let's look at 16. We have log base 5 of 16 is equal to log base 5 of 2x plus 4. Those bases are the same, so I could do my hook method if I want to, but I already know that if the bases are the same, I can cancel them out on both sides. So this one would become 16 is equal to 2x plus 4, which I can then minus 4, minus 4. So we get 12 is equal to 2x. Divide by 2, divide by 2, and we get 6 is equal to x. So relatively straightforward with our canceling the bases. We've done this already, so I'm going to skip 17 because I think y'all can do 17. And I want to talk about 18. It's the only one that's a little different. So I have natural log of 4 plus natural log of x minus 4 is equal to the natural log of x plus 5. So on this one, bases are the same, but I have 2 natural logs while only 1 on the other side? Well, I have to have a single set of bases that are the same on both sides. So before I can combine this, or before I can cancel the bases, I got to cancel, or not cancel, combine my left side. So I have addition on the outside, which means I can combine it into multiplication. So this is going to become the natural log of 4 times x minus 4. And that would, of course, would still be equal to the natural log of x plus 5. Then from here, I actually don't have to simplify the 4 times x minus 4 yet, but I'm going to go ahead and do it just so it can make it a little bit easier once I do cancel the bases. So this would become 4 times x would be 4x, so the natural log of 4x. 4 times negative 4 would be negative 16, so minus 16. And of course, that's still equal to the natural log of x plus 5. Then from here, now that I have a single log on both sides, I can cancel and cancel. We get 4x minus 16 is equal to x plus 5. So minus x to both sides, add 16, add 16, and we get 3x is equal to 21. Divide by 3 and divide by 3, and we get our final answer of x is equal to 7. And my cursor is going to stop cooperating with me. So on that note, the rest of these on this page you should be able to use and solve using your combined skills of solving logarithms. So I want you to try 17, 19, 20, and 21. And if you're feeling up to it, you can try the challenge questions, or you can just wait and I'll talk about them at the very end. All right? All right, y'all, I'm going to go through these rather quickly so I don't take too much more of your time. So 3 to the power of x minus 9 is equal to 3 squared. Same base of 3 cancels out. X minus 9 equals 2. Add 9, and we get x is equal to 11. So 17 should be pretty straightforward, hopefully. Ooh. Move something. There we go. Okay. 19, we have 5 squared is equal to 25 to the x plus 2. So we need to change that 25, so we change it to a 5 squared. And then power to a power, so 2 times x plus 2. I have to remember to distribute to that x plus 2. So it becomes 5 squared is equal to 5 to the 2x plus 4. 5's cancel out. And then I'm just solving for x from there. So I get x is equal to negative 1. In the case of 20, I have log of x plus 2 minus log of 4 is equal to log of x. So let's condense that first log. It's a subtraction, so we condense it into division. So log of x plus 2 divided by 4. They are the same base, a common log, base of 10. So cancel out log, cancel out log. I get x plus 2 over 4 is equal to x. Multiply the 4 to both sides. X plus 2 is equal to 4x. And then we're just solving for x from there. 21, there's one little trick to it that's a little hard. Okay, so on the left side, natural log of 2 minus natural log of x. Combine those logarithms into a single natural log of 2 divided by x. Over on the right side, though, we have that negative in front. So I need to bring it in and make it a negative first power. So natural log of x minus 1 to the negative first is the same as the natural log of 1 over x minus 1. That negative 1 power is going to send the x minus 1 down to the bottom. Then I have natural log and natural log, cancel out on both sides. So 2 over x is equal to 1 over x minus 1. I can cross multiply because I got a fraction on both sides. I know y'all have been waiting to do that all year. So we get 2 times x minus 1 is equal to x. We can distribute to get 2x minus 2 is equal to x. And then solve from there. We get x is equal to positive 2. And I'm not going to talk through the challenge questions because really and truly, they're a little harder than anything I would really give you. But I did want you just to see them. And of course, the key is posted on Canvas as well. So you can kind of work and look through these steps a little more intensely there if you would like to. But that pretty much sums up all of our log skills, y'all. This is about as hard as it gets, these notes today. So I want you to work through the homework, work through some of the practice. We're going to talk about this on our review day next time. But that's all I got for you. Thank you.